The Internet History Podcast is brought to you by MetaLab. Their slogan is MetaLab, we make interfaces. For a decade, MetaLab has helped some of the world's top companies and entrepreneurs build products that millions of people use every day. You probably didn't realize it at the time, but the odds are you've used an app that they've helped design or build. Apps like Slack, Coinbase, Facebook Messenger, Oculus, Lonely Planet, and many more. MetaLab wants to bring their unique design philosophy to your project. Let them take your brainstorm and turn it into the next billion-dollar app, from idea sketched on the back of a napkin to a final shipped product. Check them out at metalab.co. That's metalab.co. Welcome to the Internet History Podcast. I'm your host, as always, Brian McCullough. Today, we continue my efforts to preserve the history of the ISP industry, Internet Service Providers. These days, it feels like the Internet is simply all around us all the time, but there are amazing entrepreneurial stories about how that crucial infrastructure was laid. Today, we talk to Sonic founder Dane Jasper, who can not only give us the history of the industry, because he's been there from the very beginning, but the present-day situation as well, as Sonic is still a thriving and important independent ISP. Please enjoy this conversation with Dane Jasper. Dane Jasper, thanks for coming on the Internet History Podcast.
Thanks for having me.
Well, this is kind of my generic first question, but I feel like it's super relevant to this conversation. And that would be, what was your first experience online or with the Internet, especially because that's the business that you eventually got into. But do you remember your first time going online?
Well, as a kid, it was dial-up bulletin board systems, pre-Internet. And so kind of early memories were, using an Apple IIgs to dial up to local, single-line bulletin board systems and, busy signals. And, I used to have like a manual dial modem. You'd dial and then flip the switch over and, monitor the thing synchronizing and then connect it over to data. So that all sort of predates the Internet. And then, the beginning, and that sort of, went through from those sort of isolated systems that had no interconnection to beginning to participate in systems that were part of networks like FidoNet, and then later, UUCP and email. And then when I went to the Santa Rosa Junior College, the Santa Rosa JC was the first community college in California to get an internet connection. And when I joined the university, I really enjoyed work more than school. And I had actually dropped out of high school when I was 16 and worked for a couple of years, and then worked for an online service and discovered that's what I liked doing. And I went back to the JC to learn computer science. And so one of the first things I did was get a job in one of the labs there and get exposed to the internet in the college environment.
So you said that this was Santa Rosa JC was one of the first, or maybe the first in California to hook up for the students. You mean, not for research purposes?
Well, to my understanding, it was the first community college in the state of California to get an internet connection, and the Santa Rosa JC led a consortium of community colleges, and they had a set of software developers who were staff at the college who wrote the software that was used for student records and for some of the human resources and personnel activities. And so because the Santa Rosa JC wrote this software, and this was, mainframes and COBOL and, raised floor data center and, a number of software developers that wrote this thing. because this college was sort of the nexus of this platform that so many used, it was the first to sort of have the justification for getting an internet connection, which was, and remember this is a huge college. The enrollment was about 26,000 students. As I recall, there were 800 PCs on campus that were, staff and faculty computers and lab computers. And the internet connection that the campus got was a 56 kilobit connection.
Mm-hmm. So you get a job essentially building this out, like getting the university wired?
Well, my first job was in one of the labs. So I was, someone who'd help somebody with, their computer homework, what they were working on, whether that was, an application. People were learning WordPerfect and whatnot. And then I moved to a position in the computing services department. And so I was a student employee. And our job, and there was a number of students, 3 or 4 of us, and then staff who ran this as well. And our job was to support the campus desktops and laptops. So we were a repair center, so to speak, for companies like HP and Apple that the campus bought equipment from. So we would do sort of in-house warranty repair. And also, our job was to hook up the 800 and some campus computers to this new internet connection. And so that meant crawling around under desks and, connecting, thin net, coaxial cables and terminating cable and installing Ethernet cards into, like Windows 3.0 computers, loading drivers, trying to make all that stuff work. And so, the primary job was, managing the distribution of that internet connection. And, this is a campus, so it's a widespread environment. So it was the complexity of connecting from building to building and deployment of, this is pre-switches, so it was hubs. And it was, most of it was coaxial and then later Ethernet. And so that was kind of, early work experience.
And what year are we talking about? What year or years?
So this was probably 1991, and my co-founder, Scott Doty, was also a student employee at the time, and so co-founder of Sonic, and Scott served as our chief technical officer for a number of years. So he and I were both in that campus environment at the same time, sort of from maybe 1991 through 1994.
Well, so I bring that up because that's pretty much pre the web going mainstream. So the internet that you're setting up at first is like, straight for them, like email, file sharing, that sort of thing. And like I think I read that you even might have set up one of the first Gopher servers in California.
Well, yeah. So I mean, this is pre-web, and so the principal applications were, telnet, text-based, connecting from one server to another, file transfer protocol, downloading files from remote servers, internet relay chat. I'll come back to that because IRC was sort of a nexus for a critical moment. For us, and Gopher, was a text-based early set of menuing, linking, and document storage. So you'd see a menu, items 1 through 10. You'd pick item 2 because that was where you wanted to go. That might link to another server that had a menu and items 1 through 5, and item number 5 might be a text file that you were looking for. It's a little bit like the web, right? Hyperlinks from one server to another. And so Gopher was a little web-like, all text, but it was a linking platform from, within a file structure and a menuing structure on one server that could then link to other servers. And so Gopher was one of the things that was a little bit web-like pre-web.
And I might be screwing up the timeline here, but aren't you guys also setting up and running your systems on Linux really early on too?
Yeah, so I mentioned Scott Doty previously, and Scott was another student employee in the Computing Services Department at the San Jose JC. And Scott was a radioman in the Coast Guard, so he was on the GI Bill. And there was a semester when Scott didn't want to take any classes, and in order to get your GI Bill funding, you had to take a certain number of units of classes in order to be a reasonably full-time student in order to get your government funding. And Scott did a project proposal for, I think they called it Special Studies in Computer Science. And these sort of special studies frameworks, you would propose a project to a department. You'd say, I'd like to do this thing, and here's how this will be equivalent to taking a class. And so when you're a college student at the junior college, there's also a work experience opportunity. So you can take a work experience class. You get some units for working. And so Scott got, I think, 4 units for being employed in the Computing Services Department and 3 units for taking a special studies in computer science project. That was enough units to get, continue to get his GI Bill funding for that semester. And the project was to use this new operating system called Linux, which I think it was like 0.92C was the version at the time. Linux had gotten an Ethernet driver, its first driver for an Ethernet card, the Western Digital 8003 card, 2 weeks prior. And he said, I would like to use this new operating system called Linux to set up a dial-up Linux host that students can use to access this amazing 56 kilobit internet connection and all these resources, and in the process not go to class for a semester.
So then, is that what you guys also take? And I am jumping ahead real quick. Do you take that basic system when you start Sonic, or did you have to rewrite that sort of stuff?
Well, so Sonic was a re-implementation. So Scott and I and another student employee named Dustin Molo, and the staff who supervised us all kind of were involved in this process at one level or another. And we used a spare. We had an HP 386 that was a spare. It would have been a Novell NetWare server for one of the departments, but it was the cold spare, the spare hardware. We had a set of spare modems that would have been connected to the campus mainframe if they had a failure of one of the modems. And we borrowed the spare equipment. And I remember the approval for the project, and he got approval from both the Computing Services Department that was going to support it, from the Computer Science Department that had the faculty who were going to supervise this project. And it said, the project is contingent on the availability of spare hardware, and if one of the departments has a server failure, then you're going to lose your hardware, and you'll have to then sort that out from there. And so Scott really drove this, and the rest of us who had been playing around on the internet and enjoying it assisted him. And so you mentioned Gopher previously. One of the things I did was set up the campus Gopher server on top of that platform. And this was the campus mainframe was Garfield. The campus library system, the mainframe that ran the library catalogs, was Odie. And this little Linux box that we set up with, I think, about 8 phone lines and 2,400 baud modems that students could dial into was called Nermal. The little kitten, right, in the Garfield comic. And so jumping ahead, so to speak, we'd been operating the system for some period of time. Maybe it was 9 months or so. And maybe a year. So this would have been 1993, perhaps, early 1994. And we got a phone call from another college. And as I recall, it was a 4-year university. And they called up the, junior college. And they said, one of your students is cussing in internet relay chat, and we would like you to call them and tell them to stop. One of your junior college students is being rude on the internet, and that is inappropriate, and so you should give them a call. And we logged into IRC and we went into the channel this kid was in, and his name was Max Watson, and he's in some IRC channel, dropping F-bombs and just being what we would think of today as a troll, and just behaving really badly. And so we trot down the hall and sort of up the stairs to the area where this raised floor data center is, and the programmer who was our liaison with the system, his name is John Mercer, and we go into John's office. He's this, COBOL programmer, sort of classic developer. He says, John, we have to call this kid and tell him to stop cussing on the internet. Can you look up his student record and give us his telephone number? And so we look up Max Watson. No student record. Couldn't find him. And we tried a few different variations of the name, and couldn't find this kid in the student records. And the way that this platform worked, so you had this data center where all the campus infrastructure is, and this includes student records, right? This is where everybody's grades are. And I'm sure you've seen war games and, the idea of hacking the student records and giving yourself an A. Mm-hmm. So they didn't trust Scott and I with direct access to student records. And what this was a serial line, a flat satin cable that ran up into the, under the floor of the data center, up into the ceiling above, down the hall to this old electronics lab that Scott and I worked in, to this Linux box that was sitting on the workbench there. And the protocol was, and John Mercer wrote the software on the mainframe side, we would send to John a social security number and a birth date. This is before, identity theft, and people cared a lot about social security numbers. Your social security number was your student registration. And so when a student wanted access, they would log into the system as new. That would spawn a little program that Scott wrote that would say, what is your name? What is your social security number? What is your birth date? And it would assign a login and a password for the Linux box. And then it would send the information over the serial line to the campus mainframe. Now, we were kind of novice programmers back then, and matching names was kind of hard. And so we would send over the social security number and the birth date. John Mercer would compare that to the student records, and if that was a registered student in the current semester, he'd squirt back a 1, a yes at us, and if not, a 0. And we never sent the name over the campus mainframe. So we trotted back to our office, and there was literally a flat file of these social security numbers, birth dates, names. And we looked this up. We go back to John's office. Here's the social security number that goes with it. And he looks the social security number up, and it was an older woman, I think her name was Mildred, a 78-year-old woman who was registered for aquatic aerobics at the local Santa Rosa JC. And clearly this older woman was not acting like a teenager in internet relay chat and trolling people. And so this was kind of an early form of identity theft. And so we asked around, and the campus really operated on student labor. They by law, they could pay below minimum wage. And a lot of students would work in in different departments, including registration. So what we learned was that when an older person would go in and register for a class that was not computer related, there was someone in registration who was going, oh, this is an older person registering for, some sort of an art class or a PE class. And this student employee with less scruples than we had would literally jot down the Social Security number and the birth date on a yellow Post-it note during the process of registering this person for their classes. And this individual had a younger brother who was a student at the Santa Rosa High School next door. And they were selling these Post-it notes that could be turned into a semester, 6 months of completely free, unfettered access to the internet. They were selling these at the high school next door for $25. And that was the kind of light bulb moment for me. And I said to Scott, people are stealing this from us. And, this is an era when, people were dialing up to CompuServe and dialing up to AOL, and they were paying $20 a month. And you may remember they would send floppy disks and CDs, and it would say...
Well, I was going to say, I'm going to interrupt. This is not $20 a month. They were still charging by the hour.
Well, exactly. So you'd get the CD, and it would say 720 free hours, right, in your first month. And you'd sign up. You'd pay $20 a month plus $1 an hour. And that was sort of the going rate for online services back then. And the reason for that was that they had to have a local phone number in your area, and they had to trunk that back to somewhere else. And, this was expensive in that era. And so the idea that you could give a 15-year-old $25 for a Post-it note that was the stolen identity of a junior college student and get 6 months of free internet allowed them to go online to the directly connected, a Linux or Unix shell environment that allowed direct access to FTP and IRC and Gopher and Telnet and email, all those components, and not pay $20 a month plus $1 an hour. It was really a valuable commodity. And at that moment I said, Scott, we know how to do this. And this Linux platform's been working great. This is, a Linux server and some modems and a 56K connection. And we should go replicate this at my mom's house. Sort of this is like the back, the garage startup story, the back room. Let's just do the same thing and charge for access. And we think that there's a business there.
Well, where did you, though, maybe I'm getting ahead again. So if I understand correctly, you literally, get a couple phone lines set up for your mom's house, buy some modems and things like that. But where did you think you would identify customers aside from going back to the high school?
Yeah. Well, yeah. We got permission from the Santa Rosa JC to notify the students who were users of that platform that this commercial option was available. And I remember we had to sort of write a letter to the campus leadership and say, we want to send an email to everyone or put in a message of the day, a text that will display when you log in that says, there's this new commercial service that's very similar to this, but, costs $12 a month. And, tell your friends about it. And I think they probably gave us permission because they recognized the problem with non-students having access and that this was a way to help resolve that. But so we notified the users of the system that we were already operating, and then second, we ran classified ads in the newspaper. And this was a time when that was still a thing. Ironically, the internet obviously has killed that. So we ran classified ads in the paper, dial-up internet access, and at the beginning it was just text shell-based access, and then shortly thereafter we launched point-to-point protocol, and serial line IP, and those protocols allowed us to deliver IP, and that opened the door then to folks accessing directly resources like web servers and running a web browser.
So I think that you were able to run it out of the back room at your mom's place for a while, but then Pac Bell wouldn't sell more than, I think, 17 phone lines to a residence or something like that.
Yeah, well, it was interesting because I was running this while I was a student, while I was working on the campus. I was working another job as well at the time. And so this was an evening time thing. I would get home each night from work after school, and I would go to the local post office, and we had a P.O. box. People would mail in a check. They would pay $50 one time, sort of sign-up fee or setup fee. That bought basically 1/10 of a modem, a phone line, and a terminal server port that we plugged it into. And they would pay $12 a month, and they'd pay 3 months at a time. So we'd get a check for $86, 3 months of service, and a connection fee. And each day I would go to the P.O. box at the end of the workday. I would open up the P.O. box. There'd be, 3 or 4 or 5 of these checks in there. I'd walk across to Kinko's and photocopy the checks. I'd write up a deposit slip. I'd put them in the bank. I'd go home and I would call these folks and say, okay, well, let me help you get your modem set up your computer. A lot of folks back then didn't have modems, so I'd make house calls, go out and help folks install a modem, get it up and running. And we reached a point where we had, like you said, I think 17 phone lines in the house, which isn't really typical. And remember, this is a time when people were getting second phone lines for either fax or a modem. Online services were really beginning to grow. People were dialing into those online services and early internet services. And so lots and lots of households were getting a second phone line. Well, we were getting, a 17th. And this is growing so quickly that I placed an order for 8 more phone lines at a time. And so I got home from work one day, and there's a message on the machine, and it was the local BIC engineer for Pacific Bell, and he was saying, hey, I've got this order here for 8 phone lines, and we don't have the capacity on your street to deliver these, so give me a call and we'll talk about it. And so I was panicking, and so the first call I made was to the California Public Utilities Commission. And this is like 8 o'clock in the evening, on a Thursday or something, and obviously nobody's there. And I get an answering machine or something, and I leave a message with the Public Utilities Commission, and I said, I just want to order phone lines. Don't they have to sell me phone lines at this house? And then I hung up the phone and I called back the engineer at Pacific Bell, and I said, all right, I really need these 8 phone lines, and I've called the Public Utilities Commission to find out what my rights and responsibilities are. And, please call me back. And the next day, the Public Utilities Commission staff called me, and they said, well, everyone has a right to a phone line. There is a universal service obligation. In other words, if your neighbor has a phone line, you should be able to get one too, and you should be paying the same rate as everyone else. And this is, a carrier of last resort concept, an obligation. And I said, well, what about, 20-some phone lines? And they said, no, they really only have to sell you one. And so I was disappointed, and went to school and went to work and came home and found a message on the answering machine from the engineer at Pacific Bell. And he said, all right, we've sorted it out, and we've got a way to deliver these lines for you. But after this, you can't have any more. And by the way, what did the Public Utilities Commission say? And I called him back and spoke with him on the phone. I said, well, they told me I was out of luck. And what had happened was, you think about a street of homes, block after block after block of homes, and I had consumed 17 phone lines kind of in the middle of this street from, one end to the other. And there were homes further past mine who were trying to order modem lines. And I had used up all of the copper wires that went that far. Mm-hmm. And so this engineer said, well, we're going to run a new line as far as your mom's house, and we're going to migrate all your lines over to that. But I'm only doing that because I can't take these lines away from you, and you've used up so much capacity that we can't serve the homes beyond you, and everybody wants a second phone line now. And so he said, look, you got to move to a commercial location. And so these 8 phone lines bought us a couple months of growth and allowed us some time to find an office building downtown that, it seemed really well equipped. It had 300 phone lines into it. And, we said, well, here's the offices we're considering. And he said, well, choose that one. That one's got the most phone lines.
So I'm assuming that at that point, if it hadn't already occurred to you before, you're like, this is the moment where we have a real business here.
Yeah, it was interesting because, I had, like I said, I quit high school before finishing when I was 16 and, went and worked and really found my passion in online services, went back to the JC, was really succeeding and doing well in school and taking lots of units, and started the business in 1994. So it'll be 25 years in a couple months here. And so I look at my transcripts from sort of 1994. I'm taking 21 units. I was on the swim team. I was on the dean's list, doing really well. And then the next semester, it's like 18 units and, getting some Bs. And the next semester, I'm taking 12 units and getting, withdrawing from classes. And so there's this like decline in my academics as the business really started to grow. And, fundamentally, I got to say, we were in the right place at the right time. The internet was taking off. People were getting online. And so there was a lot of good luck in that.
Yeah, I've used the phrase many times on here before, like, if there's a tidal wave of history, all you got to do is stand in front of it sometimes and try to ride it and don't get wiped out by it.
Yeah, figure out how to ride it instead of getting drowned. There's been, a whole sequence of great people and great decisions and good strategy that have kept us and sustained us through those years. And that is a time, if you think of the mid-'90s, that was really the time of the rise of dial-up internet and ISPs. And this is before, cable internet existed as a technology. It's before the telephone companies had gotten into the business of providing DSL and their own retail services. So if you were on the internet, you were online with an independent commercial ISP, and that might have been, by way of CompuServe or AOL, who had sort of portals through to the internet, or an independent ISP that was serving your region or community. And there used to be a book of like a directory published every year. The Boardwatch magazine published this book it was like a phone book for ISPs. And there were thousands, like literally thousands of internet providers. And you'd look up your state and your area code. You'd find one with a local number. You'd dial into that number. You'd kind of find out what they offered. And that was really an interesting era of innovation and businesses growing, and all founded on, and we talk a lot today about common carriage and net neutrality and sort of the important telecommunications regulation concepts. Well, that capability to deliver dial-up internet was founded in the fact that phone lines were the technology that was necessary, and telephone lines were common carriage. They were available to every business at a tariffed rate on an equal basis. And that was the key ingredient.
Well, aside from the galaxy of mom and pop, as it were, ISPs that you're probably competing with locally, as the 90s evolve, eventually the thing that is the training wheels for a lot of Americans for the internet is AOL. So what about competing with the likes of AOL and CompuServe and Prodigy in terms of becoming people's ISPs versus doing something like AOL?
Yeah, I mean, it's an interesting one because, you think about today's carriers. Largest broadband provider in America is NBC, Universal, Comcast, right? And, AT&T, DirecTV, Time Warner. What you see today is this creation of access behemoths who are also deeply integrated with content, owners of content and content distribution. Well, back then, you had the same sort of scenario with America Online and CompuServe and these portals that were rich with content and advertising and chat rooms and their own kind of walled garden of siloed resources. On the one hand, right, at $20 a month and $1 an hour, and then on the other side, you had the rise of ISPs and just the internet. And what happened was AOL users stopped looking at AOL resources, and they just used it to get to all the wonderful things that were on the open internet. And so the rise of the internet and its sort of generic ubiquity and broad scope of global resources made it possible for a mom and pop operator who was just providing a dumb pipe, who didn't own or curate content or run chat rooms and so on, instead could just provide a connection to this wonderful internet thing. And consumers actually wanted that. They didn't want to fuss around with all the content that was owned by their provider.
We mentioned this before, that there was a time when AOL and CompuServe and all of them are charging by the hour. And as I understand it, one of the things that made them go to unlimited were the independent ISPs that were just like, just pay us a flat fee per month, and you can use it all you want, right? Because all you just want the open internet, so we don't need all these bells and whistles. So was that also a strategy that was commonly employed to compete with the bigger players?
Yes, and the local ISPs had the advantage of having local phone lines. So you think of America Online, they have a few data centers where all the modems are across the country. They have to trunk the analog voice calls to those points. They have to pay intermediate carriers to do that. The local ISPs bring a big internet pipe to town, and then they buy local phone lines. They receive local calls, and they pay nothing per minute. So the shift in the business model and the key innovation platforms, I mean, Linux is one. The rise of free open source operating systems that allowed for delivery of these services, services that were critical like email, web hosting. So Linux and free open source software was one critical component. And consumers' desire just to get to the internet, the rise of the web and the ease of use of the web was another. They didn't want CompuServe, they wanted the web. And then the last was local phone lines allowed a local service provider to eliminate the toll per minute that they might pay for an intermediate carrier and just receive local phone calls and connect those directly to the internet. And so I think a lot of ISPs ended up, selling services, and they would perhaps cap the total number of hours people would use, and just charge a monthly fee, kind of under $20 a month. And our price point, we've always been an aggressive price leader and a disruptive carrier from that perspective. Our launch price point was $12 per month for what became unlimited dial-up internet. And what we learned was that we needed one phone line for about every 10 users, and they would sort of dial up prime time, kind of 1 out of 10 moments, and that drove the economics of the entire business model, was what that utilization was.
Well, this is alighting a bunch of stuff, but the AOL famously does not survive for forever, and because they essentially bungle the transition to the broadband era. And even though they try, that's part of what buying Time Warner is. It gets you a cable company, essentially, and the telcos are getting into the business. So how does Sonic, survive this transition from essentially the copper wire infrastructure-based business to the broadband business that evolves into all these different technologies?
Yeah, it is really interesting to look at the history of this, because you look at, online services like AOL that provided value that was only accessible by subscribing to their service, being disrupted by dial-up internet providers who had local phone lines and just provided access to the internet. And then as we move into the broadband era, cable companies who own the wires that go to the house, and phone companies who control twisted pair lines that go into the house, delivering, DSL and, data over cable. And so, internet providers disrupted online service providers like AOL, and then infrastructure owners like cable and telco over time disrupted ISPs. And so you look at the thousands of ISPs that were published in that book of service providers by Boardwatch magazine, and the vast majority of them are gone. The challenge for us, and the challenge that we've managed to navigate, has been the evolution from dial-up to DSL using the incumbents' equipment, to being a telephone company ourselves, a regulated public utility, to engaging in construction and deployment of fiber optic networks in the last mile. And so each of those, over 25 years, has been an era of learning new skills and capabilities, employing people who can help us learn how to do this, and stretching the capabilities of our organization and our team. And each of them is grounded in technological changes, marketplace changes, and regulatory changes. So, the beginning of dial-up is about learning how to run modems and phone lines and terminal servers and Linux and operating systems that allow you to deliver the authentication and DNS and all the ancillary underlying services that are necessary. As DSL arrived, so around 1998, incumbent telephone companies began to deploy DSL access multiplexers, or DSLAMs, in telecom central offices. And they were sort of driven to do so by the competitive pressures from competitive local exchange carriers, companies like Covad and Northpoint and NewEdge and Rhythms. These companies were leveraging the 1996 Telecommunications Act, which I'll come back to deploy DSLAMs, and the telephone companies really needed to do the same in order to deliver broadband internet access. But telephone companies then were not allowed to provide retail access to the internet. They could provide telecommunications services, common carriage, a connection from A to B where the traffic was carried. And so internet service providers of that era would buy an aggregation circuit, a large data circuit from the incumbent carrier, and then would buy the DSL tail, the loop to the home, that would interconnect to the incumbent's DSL access multiplexer. And we saw a lot of companies, interconnecting with lots of incumbent carriers all across the country. And so you think about companies like Earthlink, who provided national DSL access, companies like Net Zero. So this was really for us kind of the second big era. And that was learning how to run large ATM, asynchronous transfer mode switches. So this was a packet switching telecommunications technology that would allow us to differentiate virtual circuits that connected to the households and businesses of thousands of subscribers. Each virtual circuit had a sort of header identifier, and you would overlay on top of that IP, and they would get an IP address, and you would carry their traffic to and from. And sort of that kind of began in 1998, and Sonic had grown to a pretty substantial scale in dial-up access. Those 300 phone lines that were in that building turned out to serve every business down the block, and we used them all up and had to put in another 1,200 phone lines into that building. And so we had a lot of dial-up customers, and so we were able to interconnect with then Pacific Bell and offer DSL services to households throughout much of California. So we would trunk from different toll areas throughout the state and interconnect these large ATM aggregation circuits. And Sonic began at that point running an open network and providing those services to smaller regional ISPs all around the state of California. And so those regional service providers really helped us attain scale in those DSL services.
And so then what's the era beyond the DSL era where are we moving completely away from copper at this point?
No, so DSL is delivered over a copper pair, and it's higher frequency, right? You've got lower frequency that carries voice, and then the higher frequencies of the spectrum over that copper line deliver an asymmetric digital subscriber line that might deliver, in that era it was 1.5 megabits to 6 megabits of connection to your ISP, who would then connect that to the internet. And this was, during this era, Pacific Bell Internet launched. And so suddenly, for regulatory reasons, the telephone company itself could get into the internet access business. Cable companies were beginning to deliver, data over cable. And this was a chaotic, and it was a time of a lot of growth for a lot of internet access companies. And but this is still delivered over copper, and it's an interesting history here for me because regulation drives the business models and opportunities of each era. And so if you think about the era from 1992 to the year 2000, you had a Republican Congress, you had a Democratic president, Bill Clinton, and in 1996 we had this bipartisan passage with the Congress on the one side, the president on the other, this bipartisan passage of the 1996 Telecommunications Act. The 96 Act created a framework for the unbundling of last mile copper. So telephone lines were a monopoly. Every household needed a telephone line, and telephone lines were provided on a rate of return. In other words, whatever it cost the local phone company to build these wires to all the houses, eventually they would make back those dollars and a defined profit margin through the monthly service fee that they charge for basic telephone service. And so each year, your local telephone incumbent would go to the regulator and say, well, here's what we spent building and maintaining the copper network that we're providing services over. And so as a result, next year we'd like to charge $10.85 a month for a phone line. And if you think back a little earlier, long distance had been a monopoly. You had AT&T, and calling across the country was very, very expensive. And Congress and the FCC deregulated long-distance access, and that resulted in the launch of companies like Sprint and MCI, and dialing 1010-321 to choose your carrier or whatever before a phone call. So what was recognized was that competitive access and the breaking of this monopolization created innovation in the long-distance telecommunications arena. What the 1996 Telecommunications Act did was open the door in both directions. Companies that wanted to provide local services, and that would include telephone service, fax lines, DSL lines, and broadband access, would have access to these copper wires that had been paid for by consumers under this regulated rate of return monopoly regime. And then once local telephone companies had demonstrably opened their copper last mile networks to competitive local exchange carriers, then those local phone companies could get into the long distance business. And that was the carrot at the other end. And local phone companies, they were barred by regulation from providing long distance. So you had Pacific Bell providing your phone line as a regulated monopoly. And then you had long-distance services. You'd choose your carrier, and there was AT&T and MCI and Sprint and 100 others that we haven't heard of. And Pacific Bell saw this unregulated Wild West of long-distance services as an opportunity. And so there was two sides of this equation. One was to create competition in local services that were monopolized, and there wasn't as much innovation as we'd like to see, and unregulated access to long distance services. And so kind of the third kind of big thing for Sonic and I think a lot of our peers was becoming a telephone company, becoming a competitive local exchange carrier, and deploying our own DSLAMs, our own DSL access multiplexers, our own equipment to deliver local and long distance phone service, and all the services that go along with that, like caller ID and voicemail and all the star code things that you dial and 3-digit dialing, calling 811 for U.S. Underground Service Alert and 911 for emergencies. And so we became a competitive local exchange carrier in 2006, and that really drove a lot of growth for us, an opportunity to innovate. And, this is a time when, at that point, the DSL services available from local phone companies and ISPs that were using the local phone company DSLAMs, kind of at that time it was like 6 megabit was the top speed, and typically there'd be 3 speeds and 3 different price points. And so we were selling 1.5 megabit service for, it was pretty expensive, I think it was $58 a month. And then for $5 more, you'd go twice the speed, and for $5 more, you'd go twice the speed again, so you'd have a 3 and a 6 megabit offering. And so this next regulatory era from 2000 through 2008, you have George Bush in the White House. The appointees to the FCC are Kevin Martin, and the FCC at that time, the regulatory philosophy was to deregulate, and what they were attempting to spur was, investment by incumbents in their networks, and they were furthering a philosophy of intermodal competition. In other words, cable is going to compete with telco, and broadband over power line. I don't think any of us subscribe to that today. And wireless and satellite and that'll be enough competition for consumers to choose from. And obviously from our perspective as a competitive service provider, we don't think that number of choices is enough. And what we've ended up with today is a duopoly in most markets. And really because of the capabilities of the coaxial technology, for faster services in many locations across the U.S., a monopoly. And that is the outcome of regulatory decision-making in the early 2000s by Michael Powell and Kevin Martin, the chairs of the FCC during that era. And so through a series of regulatory decisions, it became clear to us that if we were going to continue to service the public, if we were going to provide services, we needed to move up the food chain from a regulatory perspective and make further investments in facilities. And so the 1986 Telecommunications Act created this framework for co-location of equipment, DSLAMs and voice equipment, and unbundling of the base copper wires. What this would allow is competitive service providers, competitive local exchange carriers, telecommunications providers, to invest in the equipment, to improve the services that were delivered, and to differentiate them. And but there's an interesting moment here where we launched those services in 2008, and we'd been selling, resold access to, I think what was then SBC through kind of reconsolidation and rebranding. We had access to their DSLAMs, and we had been selling for, at that point, a decade, a set of services that were 1.5, 3, and 6 megabit, and that cost basically $5 more for each doubling in speed. And so we built a new network, and we did our first co-location, and we launched services, and we did it using a newer DSL technology, ADSL 2+, which supported, the technology supports up to 24 megabits. And so we took the three speeds that we had, 1.5, 3, and 6, and we said, well, let's create a 12 megabit tier and charge $5 a month more for that, and an 18 megabit tier and charge $5 a month more for that. And we don't think, we think that'll be the right go-to-market, the right plan. And what we found was that it didn't work. We were always growing, but there was no inflection. And, some people who wanted more speed subscribed to the faster services, but it wasn't innovative. And I, historically, I grew up quite literally in the telecommunications and internet access market of the United States, a market that began with dial-up access and then paying a little extra for 56K modem access and paying hourly for services, to DSL, where the incumbent had created these three tiers and priced them differently. And so I thought, well, that's how you should sell internet. It goes faster, you should charge more, right? That delivers more value, and it makes a whole lot of sense. And that makes sense when you buy something offline. If you go and buy a single hamburger, you pay one price, and if you buy a double cheeseburger, you're going to pay more. And that is capitalism and correct and appropriate. But the reality there is there's more cow there. Whereas if we're just limiting the DSLAM or router to 3 megabits instead of 18, that's literally us just logging in and changing a setting. The underlying infrastructure, the wires that go to the premise that we rent each month, the DSLAM in the central office that delivers the ADSL 2+, and the modem in the home, all of those can go any speed. And there's some limits based on distance and some practical limits, but what we did was launch a service based on the segmentation of price model that was common in the U.S. And this is a model that really, frankly, was the outcome of a failed market, a market that became a duopoly of, cable versus telco. And cable would go a little faster, and they'd have 3 or 4 different tiers of speed. And then telco would go a little faster, and they would have a few different tiers of speed. Cable would upgrade their network a little, telco would upgrade their network a little. And it was really this glacial pace of duopoly innovation with these two companies sort of looking across the aisle, so to speak. How fast is their network? What's the technology they can and will deploy? How will they invest? What are the return obligations in those investments? And then what are the price signals that they're sending in the marketplace? And what's our churn? And how many customers are we losing? And so we launched a set of, what we hoped would be innovative competitive services, emulating a business model that was designed to maximize the wallet share in a duopoly environment. And the result was, kind of uninteresting. And we're focused on the technology. We're focused on the product and the customer service. And we just had not figured out the business model. And I think given the sort of deregulatory environment in the United States from 2000 to 2008, and the by and large failure of the bankruptcies of the majority of competitive carriers that launched in the late 90s, all kind of went bankrupt in 2001, 2002, when they had this big .com crash, and we just didn't have domestically a good framework for what competitive access should look like, and so I started reading about competitive service providers in Europe, and Europe adopted a telecommunications regulatory framework that emulated the U.S. model of taking state-owned or privately owned monopoly telecommunications carriers who had operated on a rate of return basis, built unique last mile essential infrastructure, and required those incumbents to unbundle it and create a competitive framework and opportunity. And then the European regulators stuck with this, whereas in the U.S. we passed the 1996 Act, and then ever since then, up until the present moment, it has been an effort to unwind that by incumbent monopolists. And there was some success in that in a number of decisions. There's a fiber forbearance decision. If the incumbents built fiber to within a certain distance of the home, they had no unbundling obligation. This is really what led to the UVerse product. And I remember a threat by the then CEO of SBC that they would not invest in this infrastructure if they didn't receive regulatory relief around wholesaling obligations. So the idea was deregulate to spur investment, and to some degree it's worked. Cable operators have taken a lot of the telecommunications market from telephone companies. Telephone companies are deploying networks to take customers back. You think about companies like Verizon building the Fios network. And but I think where we've ended up is, by and large, this duopoly environment, and Americans pay far too much for the internet access that they have, and they have few choices, which leads to the companies who know that they are virtually a monopoly or oligopoly at best, making decisions about how traffic would be treated. And you think about the outcomes of the neutrality. Well, if you had 20 providers to choose from, we wouldn't need to regulate net neutrality because the market would take care of that. Similarly with privacy, service providers who engage in turning their customers into their product, and the need for privacy regulations. Well, if you had 20 service providers, so long as there's transparency about privacy practices, you probably wouldn't need much in the way of privacy regulation because consumers would choose in the marketplace the product that met their goals around privacy. And so Europe, on the other hand, adopted a framework that looked like the U.S. 1996 Act, ratified it across the member nations, and implemented across the member nations in Europe at a later era than the U.S. and then stuck with it. And so, if you are in the UK or France today, you have many service providers to choose from, and the result has been lower prices and more product and service innovation. And so I started reading about the European marketplace and what, how competitive it was and what the prices were, and critically, what the products were that were delivered. And what I realized was that in an environment where your underlying cost structure is the copper wires that go to the premise, and the copper wires can carry what they will, that is data and voice, and data at whatever speed can be carried based on the distance, that the right model isn't 5 different speed tiers for 5 different prices. It is to deliver as much as can be carried over it in data and voice, unlimited use, unlimited local calling, unlimited nationwide calling, all of the voice features, all the things that, caller ID today, many local phone companies charge over $9 a month for caller ID. And that just doesn't make any sense. Voicemail, people are paying $6 or $7 for voicemail service, which probably made sense, 15 years ago when that was really expensive technology. But today, that's literally a small Linux server, and or an array of them. And so in the late 2000s, we really reinvented the product, and we launched our Fusion broadband and phone service, initially based on ADSL 2+ technology. And we included data as fast as it would go, and unlimited phone service, unlimited local calling, unlimited nationwide calling. Eventually, we added unlimited global calling, so our customers can call fixed lines in over 60 countries and pay nothing per minute for it, and nothing per month. It's part of the bundled service. And that recognition that we'd been competing in a failed competitive marketplace, and we were executing business models that were based on duopoly, was really another light bulb moment for us. And we quickly kind of recast all the products, de-tiered them, flattened all the pricing, and launched a product that was, as fast as it would go and unlimited use. And this is kind of the third of 4 eras of the company. And during this time, we continued to operate an open network. We had about 75 service providers that used our open incumbent DSL aggregation platform, and we carried about 10 of those over. The 10 that were really still serving the markets that we deployed in and still growing. And we deployed our own equipment into nearly 200 central offices in California, greater Los Angeles and Orange County, Sacramento, the greater San Francisco Bay Area. And so that was really kind of the third major evolution of what we've done.
So what is the 4th era then?
So I like you sort of raised to the leading cause there. So what's next is the last mile, right? The challenge is the copper doesn't go fast enough. And, we have taken, we as an industry, right, cable has taken a coaxial plant that was CATV, community antenna television, that was designed to distribute a signal from a mountaintop that could see a large city down into the valley and allow many households to share an antenna. Telephone carriers have taken twisted pair technologies that were designed to deliver a dial tone and voice communications to a central office, and we've overlaid higher frequency signals and deployed fiber deeper into the network and deployed faster and faster, better and better data technologies to deliver internet access fundamentally. But copper only goes so far, so to speak. And the reality of the DSL technologies today, today we deliver VDSL2, which is kind of the most broadly deployed high-speed DSL service, and it can deliver 50 to 100 megabits of internet access, but you've got to be pretty close to the central office to get that. And there are some newer technologies, G.fast, that could deliver, hundreds of megabits and with some pair bonding over a gigabit, but on the order of hundreds of yards. So this is an in-building, you think of an apartment building or an apartment complex. It's a distribution technology that allows the last hundreds of meters to be faster. The challenge is when you've got to go 2 miles to reach a home, twisted pair, there's limits to the capabilities. So the solution is to deploy a new network, and the challenge is how do you do that competitively, how do you fund that and build that. And for us, what that has become is basically to follow the roadmap of the 1996 Telecommunications Act. So the Act is intended as a competitive environment that allows for access to the old wires on a shared basis. And that is an essential component because whether you're a cable company or a phone company or a new market entrant, you don't suddenly have thousands of fiber-connected customers. You begin with copper-connected customers in a community, and then you build a fiber network when there is financial viability and market demand, and then you migrate those customers from copper to fiber. And so Sonic's business model and approach has been to deploy competitively differentiated copper services. So unlimited use, the right policies and practices, good customer service, fast technology like pair bonding to merge 2 lines together, VDSL2 for folks that are close to offices. So deliver a service which is high performance, differentiated, and accumulate customers in a market, and then build a new fiber optic network and migrate those customers to that optical network. And so the really fourth major story of the company has been the process of learning how to build outside plant, last mile fiber to the premise. And that brings all the way from the internet and content delivery networks and peering and transit through an optical network to access equipment that brings fiber optic cable all the way to the home, the side of the house, where then it's converted to gigabit Ethernet and delivered to the consumer.
So what you've described in the course of this conversation is just always being nimble enough to not only stay one step ahead of the competition, but also to evolve with the technology, with always keeping your eye on, like, we just want to deliver the most stuff over whatever the infrastructure is that we can provide it on. Does that sound like a decent summation of Sonic's 25 years?
Yes, and consumers are hungry for access to all the amazing things that are on the internet, like all the great stuff that's happening. Whether it's streaming or shopping or finding a job or learning something or meeting your spouse, all these amazing applications are what drive people's desire to use this. And then as an industry, carriers, whether it's cable or telco incumbents or competitive carriers, we all have to innovate in the technology, in the deployment of infrastructure to deliver faster and faster services. And it's an amazing competitive story. And I'll also say, Sonic is not unique in this story. I think about these eras of dial-up and DSL resale and becoming a competitive phone company and deploying our own equipment and building last mile. And there are companies like Sonic that have done that arc from 1994 to the present in other markets. So we're a regional success story in California, but there's companies in Oregon, GorgeNet, in Missouri, Socket Internet, that have a similar story. And this is an interesting one because I think consumers think of cable, and they hate cable, right? Cable companies are some of the most hated companies in America. And there's this awful moment where you're moving into a new place, and you say, I got to call the cable company, get internet. Pay whatever they charge because I need internet. Because internet's essential. And I think that is a real opportunity. And the '96 Act and the Republican Congress's concepts around that framework for competitive deployment, and the innovation and investment in last mile infrastructure as a result of that is transformative, and we're thrilled to have had some success running along that route.
All right, so final question, at the risk of asking you to literally predict the future, but how do you see being the ISP industry or delivering this sort of data and connectivity over the next 25 years?
Well, my role is to think about the future. How do we position ourselves for that? What will the future be? And so I spend a lot of time thinking about, where is this going? Well, fundamentally, people love the internet, and there's all this wonderful stuff there, and that's just going to get better and better and more integrated with our lives and more seamless. There's all these issues around security and privacy and so on that fall from that. But in the big picture, it's just getting faster, better, and more interconnected. And I'm an optimist. I have a lot of hope for what that means with regards to education and equity and the development of communities here and nations elsewhere. And but what will it be? What will be the access technology? I mean, clearly we spend a lot of time on wireless devices today. And if you got the new iOS, it tells you your screen time if you're an iPhone user. And, many folks are spending more hours per day in front of a handheld device than they are in front of a desktop today. And those are supplanting, laptops, the way laptops supplanted desktops. But so the future technologies are wireless in a cellular context. And today, if that's LTE, long-term evolution today, LTE advanced, and future 5G technologies, that is an entire ecosystem of innovation and deployment. And we'll see more and more consumers connecting, particularly the devices that you wear and carry and drive, and devices that move, will clearly be connected to those networks in faster, better ways into the future. The other is satellite and particularly low Earth orbit, projects like the SpaceX Starlink product, the OneWeb product, where they will launch literally thousands and together tens of thousands of small satellites that orbit. And there's some interesting outcomes of that. One is latency. You can get, from a latency perspective, if you go up to outer space and then from satellite to satellite through a vacuum around the globe and then back down to Earth, you can get there faster as a piece of data than you can through a glass fiber optic cable. So this has some applications, high-frequency trading and market arbitrage as you think about New York to London, so to speak. But the other thing that's interesting is ubiquitous availability on the entire face of the globe, including all the wet bits. And so, this will really mean something for airplanes and shipping and cruise ships and so on. It also means a lot for rural places. If you think about a constellation of satellites like this, it covers, ultra sparsely populated portions of Australia or Africa just as well as it covers New York City. And so as you think about the rural and under and unconnected parts of the world, it will become possible for all of those to be connected. Now, all of these things, particularly as you think about mobile and 5G, there is a foundation of fiber, right? The mobile tower, the idea with 5G and particularly millimeter wave is that, where you had two towers in a city in 3G, and you might have, 25 towers in an LTE environment, you might have 2,000 towers in a 5G environment. They might be on streetlights at every corner. And all those points need fiber to backhaul them. And then, there's a big marketplace question of if consumers, and in my home, I think I have like almost 40 connected devices, right? It's smoke detectors and thermostats and security cameras and televisions and Rokus and laptops and tablets. And they all speak Wi-Fi, and they've all had Wi-Fi chipsets in them. There's, literally billions of Wi-Fi chipsets deployed. So in the home, Wi-Fi is the critical local area networking technology. And then the question is wireless from the home to the internet the right technology, or is fiber? And, clearly we're investing in fiber to the home. And fiber to the home has some real advantages in performance and reliability, and it's ready today. Whereas, wireless technologies that serve as a wireline replacement are nascent today and unproven. And I think they will have real applications, but where it is possible and feasible to build fiber all the way to the premise, that will continue to be the strongest solution for uplinking all the devices, both wired and wireless, that are in that premise, home or a business. And so we're really, really aggressively focused on raising debt, building infrastructure, investing in the communities that we serve, building fiber all the way to the homes and businesses, and critically recruiting customers. And I think that there was an era when people made a choice between lots of different service providers, and folks have kind of forgotten that was even possible. And so it's like moving to a new place, got to call the cable company, and we need to continue to raise awareness in the public that there may be an alternative in their location, and whether it's socket internet in Missouri, or GorgeNet in Hood River, Oregon, or Sonic in Berkeley or San Francisco or Los Angeles, consumers need to look at the alternatives. And so, that's another big part of our struggle now, is on the one hand building it, on the other hand selling it, and making sure everybody knows that they should look at those products. And we continue to have a disruptive approach in pricing and business model. It's an unlimited symmetric gigabit, and it's inexpensive, and so all those components too.
Well, Dane, thank you so much for not only telling the story of Sonic and how it's evolved with the times and the technology, but in a very large part, like basically giving us a comprehensive history of connectivity and the ISP industry, and just basically how we all get this data that is so crucial and to modern life.
Yeah. Well, I appreciate the opportunity to talk about it, and I think that it's something that consumers love the internet, and they don't love the companies they have to use to get there, and maybe they don't understand why we've ended up where we are. And it really is the outcome of not just business and technology, but also regulation. And and I talked about sort of the deregulatory efforts. There is a petition before the FCC today to unwind most of the remaining critical elements of the '96 Act. And large incumbents, through their trade association, are arguing that these components aren't useful or aren't necessary, and critically aren't used to serve residential consumers, and that's clearly not the case. And so this is an ongoing battle, not just in the marketplace and not just about deployment, but also about regulation. And this is something that we certainly encourage consumers. If you want competitive deployment of fiber to the home, and you want to see more than just one or two choices of access, file comments. This proceeding's going on for a few more months, and there's a website, savecompetition.com, and consumers can learn about what's going on from a regulatory perspective and can file comments and support there.
If you like what you've heard on this episode, please support us by subscribing to the podcast so you can get great news stories and conversations every 2 weeks. And please buy the book that was based on this podcast, How the Internet Happened, From Netscape to the iPhone, by me, Brian McCullough. Order it now wherever books are sold. How the Internet Happened. And if you weren't aware, I host a daily tech news podcast every weekday that comes out at 5 p.m. In that show, I tell you what happened that day in the world of tech. It's only 15 to 20 minutes long, and it's great if you love tech news. Search your podcast app for Ride Home to find the show. It's called The Tech Meme Ride Home. Thanks.